Welcome to section 4.5, Graphs of Sine and Cosine Curves. Let's get started. To begin with, we're going to talk about some aspects of the sine curve. What you see in front of you here is one cycle. We have from the beginning all the way to the end of the sine curve, which is a full period going from 0 all the way to 2 pi. So that's where we have our period. The next thing we want to note is that the sine curve has one max and one mid. The first maximum occurs at a value of pi over 2 and is at a height of 1. The next minimum occurs at a value of 3 pi over 2 and has a value of negative 1. And then we have three intercepts, 0, 0, pi 0, and 2 pi 0. Knowing these 5 points, we can very quickly sketch one period of the sine function. So what we're going to do is examine how a and b, those two variables, will affect these 5 points to give us a new curve. It is important, though, that you do memorize these 5 points when graphing the sine and cosine curve, because as we move forward, we're going to be graphing those new modified points to get a more accurate sketch. Here you see we have the same thing for the cosine curve. We have one full period going from 0 all the way to 2 pi, which is our length of 2 pi again. We have two maximums, one at the beginning at a value of 0 and a height of 1, and then one at the end at a value of 2 pi and another height of 1. And then the minimum is in between those two at a value of pi and negative 1. We have two intercepts, pi over 2 and 3 pi over 2. We'll talk more in class why these points are these specific values, but for now we want to make sure that we know those 5 points and that the general curve for the cosine starts at a maximum and then ends at a maximum as well. Alright, so our first variable that's going to modify our points is what we call the amplitude. The amplitude is the number that's outside of either curve and it's being multiplied by that function. Every point now is going to have a different height. So our y value is going to be multiplied by a. And it's important to note here too that when you identify the actual maximum, since the maximum is half of the distance between the min and the max, we're talking about distances here, the actual amplitude is a positive value. But when we're using it to generate our new point, we want to take the actual number that's in front of the function to multiply by our y value. Let's look at a couple of examples. Here we have three functions. The first one is y equals 4 cosine of 3x. Then we have negative 2 sine of x. And finally negative 4 sine of negative 2x. While we have a and b values here, we're going to focus on our amplitude. We're going to talk about what the amplitude is, what the a value is, and then what those do to our functions. So for the first example, our a value is going to be 4. The amplitude is going to be the absolute value of that, which is still 4. And what that means is our graph has been vertically stretched by a value of 4. It's going to be 4 times as tall and then 4 times as low for the maximum and the minimum values. If you look at our next function, we have a negative 2 out in front, which means a is negative 2. That's the number we're going to actually be multiplying our 5 points by to change the y values. The amplitude, though, again, is the absolute value of that. So the amplitude is 2, which again means that our graph is going to be twice as tall. And last but not least, we have a negative 4. So, one more time, a is going to be negative 4. That's a number we're going to be multiplying by our y values. The amplitude is the absolute value of that because it's the distance between points. Oops, negative 4. Which means that we have an amplitude of 4. So our graph is going to be 4 times as tall as the original one. Now we're going to look at our b value and determine what that does to our graph. Whereas a made the graph taller, b is going to condense the graph horizontally, and it's going to be changing our period. To change our period, normally for the sine and the cosine, we'd start with 2 pi. We're going to divide that by b, which means it's going to be shorter or longer than the original function. To reflect that within our points, we're now going to be dividing every x value by whatever our b value was to again make it either shorter or longer. Let's look at some examples applying this. Okay, so again we have three functions. We want to identify the b value, the new period, and then discuss how that is going to be affecting our graph. So for our first function, the b value is going to be this 3 in here. And what that means is our graph is going to be shorter. Because the original period was 2 pi, we're now dividing it by 3, which gets us a period of 2 pi over 3. That is shorter than the original 2 pi, so the whole graph is going to be horizontally shorter. If we look at our next function, our b value is going to be 1/3. So, for our period, we would divide 2 pi by 1/3, which is going to equal 6 pi. Since that is bigger than the original 2 pi period, we're now going to have a longer function. And finally, for our last function, we have b equaling 5. So we have 2 pi divided by 5 as our period. That is smaller than the original 2 pi. So we can say now that our new function will be, again, shorter. So again, looking at this, we have some patterns here. We had a whole number, something greater than 1 for these two, that created a shorter function. And then we had a fraction between 0 and 1 that created a longer function. And that's a general pattern. If your b value is greater than 1, then your function is going to be shorter. If your b value is between 0 and 1, then it's going to be longer. Alright, our a value doesn't only tell us the amplitude, it sometimes also provides a reflection. We have two cases. If a is less than 0, so if we have a negative a value, then the curve is then flipped across the x-axis. If the a value is greater than 0, however, then the curve stays the same and nothing changes. So anytime we have a negative a value, it's going to change the height of the function, and it's also going to flip it across the x-axis. In the case that our a value is actually negative, we're going to note that the minimum, our previous minimum, is now going to be flipped to be the maximum because, again, it's reflected across the x-axis. The maximum is going to change to become the minimum, and the intercepts are going to be unchanged by this reflection. Our next translation is the horizontal translation. So, if we are subtracting a c value from our function, then we're going to be moving it to the right by c units. If we are instead adding a c value, then we're going to be moving it to the left c units. And it's important to note here that the horizontal movement, either left or right, is also going to be affected by whatever your b value is. So if we have a b value that shortens your function, it's going to shorten the actual amount that we're going to be moving left and right as well. So really we should say that's going to be shifted by c over b units. And for our final translation, we have a vertical translation, which is a shift up or down. And that's going to be provided by whatever number is outside of their trig function. If you look at the a, b, and c values, those are all connected in some way to our sine or cosine function. The d value is the one that is just outside by itself, which means it could be in the front, or it could also be somewhere in the back. Just look for the one that is detached from the sine or cosine function. If we have a positive d value, they're going to be shifting the graph up. If we have a negative d value, we're going to shift the graph down. Pretty straightforward. Alright, now we're going to see how much of that you understood. We're going to try and identify all of these shifts for this graph. So, we're going to go from left to right here. That first negative 5 is our d value. Since it's a negative 5, we're going to be going down 5 units. That second negative 5 is our a value. Since it's negative, we have two shifts. It's going to be reflected across the x-axis, and it's also going to be 5 times as tall. Looking ahead, we're going to discuss our b value. So in this case, we have a 1 next to the x, so that 1 is going to represent our b value. Since it's a 1, there is no change. It's not going to be any change to our period, shifting it left or right, or making it longer or shorter. Our next value, our last value, is a negative pi. That is our c value, and since it's a negative value, we're going to be going to the right pi units. So here we've identified all 4 of our variables and discussed how they're going to affect our graph. Alright, one more example here. We're going to be discussing a, b, c, and d, and then talk about how they affect our graph. To begin with, our first letter there, the first number there, 3, is going to be our d value. Since it's a positive 3, we're going to be going up 3 units. Our next number there is 3. That is our a value, so we're going to be 3 times as tall. Here again we can see that b is equal to 1, so that is no change there. And you don't have to continually write no change if there is no change. I just want to make sure we identify that our b is 1. And then our last value, c, is negative pi over 3. So that's going to reflect a right shift by pi over 3 units. Tomorrow, we're going to talk about how all these transformations will affect our graph visually. So come prepared, ready to graph the sine and the cosine curve.